All right, so are you ready to use your brains a bit today? Because we're going deep on this one. A deep dive into attention is all you need. Bold claim for a paper title? Maybe, but we're going to see.
A bold title, yeah. But this paper, this is 2017. This paper kind of changed how we think about what AI can do. This is where the transformer model comes from. The architecture that's used for everything from Google Translate getting way better to, well, a bunch of the AI that's making the news these days.
Yeah, and that's why we had to do a deep dive on this one. This paper, it's like you're looking at the blueprints for how this whole AI revolution is happening, you know. But okay, let's not get ahead of ourselves. So before transformers took over everything, there was a big problem in AI that even like normal people would have experienced.
Yeah, exactly. Like, remember trying to talk to one of those chatbot things online before this paper came out? You'd say something and like 2 sentences later, it was like it forgot you even said anything. And it's because they used to use these things called recurrent neural networks, RNNs.
RNs. I never like the sound of those. They sound too like neat and tidy.
That's actually a great way to put it. It's like an assembly line, but for words, right? Processing each one at a time, really rigid. And that was the problem, especially for long sentences. Paragraphs, forget about it. By the time the AI got to the end, it forgot the beginning, like a goldfish.
Okay, so then this paper comes along and says, hold up, everyone. We got a better way. Attention, everyone. Okay, I'm joking a bit. But really, attention in AI. At first, I thought we were talking about making computers sit still in class or something. What's the deal with that?
So it's more about giving AI the ability to focus on the important parts of information, just like we do, right? The paper title, it's actually what it's saying, this attention idea, this mechanism, that's the key to figuring out language, not going word by word like we used to think.
Intriguing, but I'm going to need a little more than that. How does this attention thing actually work in AI?
Okay, so picture this. You're reading a sentence, but each word can look at all the other words at the same time and like figure out what they mean. That's what self-attention lets the AI do. The words can have these little mini conversations with each other no matter how far apart they are in the sentence.
So like each word gets to see the whole picture, the whole sentence, not just what's right next to it. That makes more sense. But how do they make the computer do that? Because then the paper gets into this whole thing about scaled dot product attention. I don't even know if I want to know what that is.
Yeah.
Sounds like I need a math degree.
You don't need a math degree. Think of it like a dating app, you know?
A dating app. Okay.
Yeah. So you've got your profile, right? That's your query. And you're looking for matches, obviously. Other users have their profiles. Those are the keys. And then what they're bringing to the table, their personality, interests, all of those are the values. So the dot product is like the app's algorithm, seeing how compatible your query is with each of the keys. Makes sense.
Okay, I'm following. So it's like the word is trying to find its best match to get the most useful information.
Exactly. And the scaling part. That's just the app making sure one really, really good match doesn't throw everything off, keeps it balanced. But it gets cooler. You know how some dating apps let you have different profiles for different interests? Like one for finding friends, one for other stuff. That's kind of what multi-head attention does.
Multi-head. Now we're getting fancy. So the AI has like multiple dating profiles going at once.
Kind of. So instead of just one set of these queries, keys, and values, it uses a bunch of them, each looking at the input in a different way, like having a whole team of matchmakers, each with their own thing they're good at, to find the connections between the words.
Wow. This self-attention thing is powerful stuff. But we've been talking about single words, right?
Yeah.
How does a transformer actually handle a whole sentence, a paragraph? That's got to be when it gets really complicated, right?
Yeah, so now we got to like zoom out a bit from looking at words to the whole transformer, the whole model. Imagine like you're building a machine, right? A translation machine, but super efficient.
Okay, I like where this is going. I'm picturing something very high-tech, lights, maybe a couple robots that speak different languages.
Close to it. So this machine's got two main parts, the encoder and the decoder. 1-2 punch. The encoder takes what you give it, English, let's say, and turns it into code. But the code has all the meaning, you know, like every part of it. Then the decoder, it takes that code and spits out, well, in this case, French. Perfect French.
Gotcha. So you're encoding the message on one side, decoding it on the other. But we had those old RNNs doing this before, right? What makes the transformer different?
You got it. We're ditching the assembly line, and we're all about attention now. Remember our matchmaking team? They're running the show, both sides. Encoder, decoder. But there's a few other things that make this work.
Oh, there's more. Lay it on me. What else does this AI need?
So imagine, right, this matchmaking team, they get so good at figuring out how words go together, they forget where the words were in the first place.
You mean like word order? Because cat chases dog is very different from dog chases cat.
Exactly. So that's where these positional encodings come in. It's like giving each word a little note says, hey, remember me, I was word number 2, you know. So it doesn't get lost. The math is pretty cool how they do it.
Okay, so it's like each word gets a little, I don't know, a backstage pass. So it knows where to go, and the meaning doesn't get messed up.
You got it. And then we've got these things called feed-forward networks. Think of them like the editors, maybe. After the attention stuff happens, they clean things up, make it all nice and neat, make sure the information is good, then they pass it to the next step.
Teamwork.
Teamwork makes the dream work, right? And then 2 more, we got to mention them, even if they're behind the scenes, residual connections and layer normalization. Don't worry too much about the details. But basically, they keep the whole system running smooth, like stage managers, make sure no information gets lost or anything.
So no miscommunication within the machine itself? That's good.
Exactly. Keeps everything humming. So there you have it. Attention, positional encodings, feed-forward networks, residual connections, layer normalization. That's the transformer team. But, okay, here's the thing. This paper we're talking about, it was about translating languages. Did it stop there?
That's what I want to know. I mean, transformer. Yeah. It makes it sound like it should be able to transform more than just like English to French.
You're telling me. Turns out whoever wrote this paper, they didn't just write a paper, they gave the world a Swiss Army knife of AI. And they probably didn't even know it, because it's not just language. This thing changed, well, pretty much everything.
Okay, now you have to tell me more. What else can it do?
Okay, so get this. They took this transformer, which is already amazing at language, and they were like, what if it could see?
Wait, see? Like with eyes. It doesn't have eyes.
No, not real eyes. But remember how the transformer takes language and breaks it down? Well, someone figured out you can do that with images too. So you get these, they call them vision transformers, VITs. They look at images like a puzzle, little pieces, and they work with them just like they were words.
AI jigsaw puzzles.
Yeah, basically. And get this. These vision transformers, they're as good as, sometimes better than, the best image recognition systems we had before this. It's like a whole new world for computers seeing.
That's wild. What about other stuff? Sound.
Sound, too. Speech recognition is huge.
Yeah.
You know how you can pick out one voice in a crowd? Transformers, they're getting good at that with audio, like having noise canceling built in, making music even, or figuring out different kinds of sounds.
All right. Okay. This is blowing my mind. Text, pictures, audio. They can handle it all. Is there anything they can't do?
See, that's the best part. This is where it gets really interesting, because now we can start combining these things. Text, images, even videos, and you get these multimodal models. They can understand the world at a whole other level.
So we're giving them senses, like we have.
Yeah. Exactly. And you want to know what's powering a lot of these mind-blowing multimodal models?
Let me guess, transformers.
Ding, ding, ding. We have a winner. They're really good at bringing all that information together.
This is incredible. So we've gone from the nuts and bolts of how this attention thing works to, like, transformers are everywhere in AI. But hold on, let's go back to that title for a second. Attention is all you need. Kind of a bold statement. I think it holds up. It's like they figured out the secret, you know, like how our brains do it and they put it in the AI. But is it really all you need?
It's a good start, that's for sure. That ability to focus, to connect the dots, that's what makes these transformers so powerful, so efficient. But, you know, remember those other parts we talked about? The positional encoding, those feed-forwarded network, they're all important.
Right, you can't just have the lead singer in a band and expect a whole song, right?
Yeah.
You need the instruments, the whole orchestra. But still, this is huge. This one paper practically changed AI forever.
And the funny thing is, this paper, they were just trying to make language translation better. But they started something way bigger, like those AI chatbots we talked about, the ones that actually make sense now. A lot of those, they're using these things called large language models. Basically, AI trained on tons and tons of text.
Okay, so where do transformers fit into all that?
Well, think of it like the transformer is the base model. It showed everyone how to make AI that could actually handle all that data. Billions of data points. So then you get things like GPT, right? Generative Pre-trained Transformer, that's what it stands for. That wouldn't exist without this paper. It's like they laid the foundation and then GPT built a skyscraper on top.
So all this stuff we see now, the chatbots, the AI writing stuff, it's all because of this one paper. But okay, this paper is from 2017. In AI years, that's got to be like a century ago, right? What's next? Are transformers the end of the line?
That is the question, isn't it? Things move fast, so it's hard to say for sure. But what I do know is this. The main ideas in the transformer, the attention, the way it processes information all at the same time, that's not going away. It's like they changed how we think about AI completely.
So everyone's trying to build an even better transformer now.
100%. It's like they found a new element or something and now they're seeing what they can make with it. Maybe we'll get totally new AI designs, but my guess is they'll all have a little bit of transformer DNA in them.
It makes you wonder what's next. Just a few years ago, chatbots could barely say hello. And now, AI is writing poems, making music. Crazy.
It's true. And that's why we got to be careful, right? Make sure we're building AI the right way.
Yeah, good point. Well, that's something to think about, right? Anyway, that's our deep dive into attention is all you need. Next time someone asks you about AI, you'll know what's up.
For sure. This isn't just any paper. This is a big one. It's like the blueprint for all this AI we're seeing.
Huge thanks to our expert for, well, being an expert. And to you, the listeners. Thanks for diving in with us. We'll be back soon with another deep dive, another paper, another groundbreaking idea. Until then, stay curious.